Okay, so we're talking about solving linear equations. Okay. As we get into this, it's been an interesting conversation already, but as we get into this, let's start with the first word, which is solving. It's good to see you, but I'm going to get rid of my face there. I know you'll be sad, but it's okay. I'll be back. Let's go to work. Let's start with the first word, which is solving. Okay? Because I have a feeling that a lot of you may not know what that word means exactly. What does it mean to solve? And everybody thinks, well, it means to get a number. How many people agree? All the hands went up. Okay. Solving does not mean to get a number. Solve means isolate. I say solve for, you say isolate. Solve for.
Isolate.
Solve for.
Isolate.
I say isolate, you say solve for. Isolate.
Solve for.
Isolate.
Solve for.
All right, so solve, first of all, solve does not mean that we're going to get a number. What? Yeah. It just means get that thing by itself. Isolate it. That's what the word isolate means, in case you didn't know. It means get it by itself. Okay? Linear, just for fun. Who can tell me what linear means? Straight line. Oh, wow. Yeah. Actually, but we're not drawing lines here. We're solving equations, and I don't see any lines. So somebody else, something else that we know. You're not wrong. You're right. But what's another thing? Linear. To the first degree. There's not going to be any exponents. Okay? So we're just solving simple equations that are to the first degree. Okay? All right. Let's just continue with our words. What's equation mean? I don't know. It has an equal sign. That's what it means. Equation. It has an equal sign. Okay? All righty then. All right. So let's start by solving basic equation. Before we get into this, I just want to read this first paragraph. When we are solving equations, we are attempting to, oh, look at that, isolate the variable. Hey. Well, whoever wrote this book's pretty smart. In order to determine what specific value that variable is given in the equation. We do this using inverse operations. Now, I can go ahead and tell you right now from our conversation earlier, this word inverse is a problem for us. Okay, so let's talk about it now. What does inverse mean? It means opposite. Inverse means opposite. Well, let's keep our theme going. I say inverse, you say opposite. Inverse.
Opposite.
Inverse.
Opposite.
I say in opposite, you say inverse. Opposite.
Inverse.
Opposite.
Inverse.
There's really only 4 operations in math. What are they? Wow, quick.
I know it.
Yeah, go ahead.
Adding, subtracting, dividing, multiplying.
Add, subtract, multiply, divide. They're family too. Yes, they are. Addition and subtraction are family. Multiplication and division are family. Matter of fact, if we wanted to go into a real argument, I could say there's only 2 operations.
What's that?
Actually, there's only one.
What?
Addition.
Four. Really?
Yeah, there's only one operation, really. It's addition.
We can do it all.
Because what is multiplication?
You're just adding something.
Repeated addition.
Yeah.
That's all it is.
Yeah.
What is subtraction? Adding a
Negative number.
negative number or an inverse. Get it? Division. Yeah, well, you can't do division. Yes. Division is really just multiplication of a reciprocal. And we've already said multiplication is just repeated addition. Mind blown?
Yes.
Okay, so stick with me. We're just going to stay with there's 4 basic operations because I don't really want your brains all over my wall. So let's go. Addition and subtraction are inverse operations, right? multiplication and division are inverse operations. They're opposite. Matter of fact, they undo one another. For example, if I've got some money in my pocket and you give me $5 and then you take $5 away, what did you give me? Nothing. See how they're inverses? If you take how many chickens you have at home and you multiply them by 3 and then you divide them by 3, you're right back to where you started from, aren't you? No chickens. No chickens. All right. So that's really all we need to be able to do. We need to be able to do is identify the operations that's being performed and use the inverse. If we see addition, we will subtract. If we see multiplication, we will, and vice versa. Okay? That's really all that's going on here. Let me finish out this particular paragraph. Sometimes refer to this as undoing the operations or inverse, okay, that have happened to the variable. So I know that you've already read this because you're such good students, right? And we can see this first simple equation. X plus 3 equals 8. Now, I'll tell you, one additional thing I like to say, especially as you get into more difficult problems, is to cover up the variable. So we know what we're working with. For example, a lot of you guys put that line down through that equation sign, right? You've learned that and you've done that for years. If you like doing that, keep doing it. If you don't have to, don't do it. I don't care. It's whatever floats your boat. But what am I going to move? Am I going to move the 8 or am I going to move the 3? Why the 3? Because it's with the variable and we want the variable to be by itself. We want to isolate it. That's what solving is, right? So sometimes I've had students where it's hard, they're moving or start moving the wrong one, especially when you get multiple variables, right? So sometimes it's been helpful for my students in the past to cover up the variables so they know, okay, well, I'm dealing with that one that I'm covering up, so I got to get rid of that 3, so I do the opposite, which is minus 3. Whatever you do to one side, you got to do the other, okay? So you've read this. Do I need to read any more? No? What about distribution? What about distribution? Distribute means multiply times everything in, right? And I like how this one did it. 3 times x is 3x. 3 times negative 2 is negative 6. And then we would solve it per normal, right? Which would be what? Come on, I'm right here. What would I do? Wow, quick. Minus 6, or add 6. Why add 6? Because that's a minus 6. Whatever I do to one side, I got to do the other. Okay? So it's 3x equals 18. Now what? Divide by 3. Divide by 3. X equals 6. Pretty cool? Simple. I want to go back and show you something else, though. 3 times x minus 2 equals 12. All of us are going to want to distribute that, yeah?
No.
I don't.
I do.
I don't. What is distribution? Multiplication, right? So when they multiplied it, they had to do these other 2 steps, right? Well, what's the opposite of multiplication? Could I divide this side by 3? Yes, I could. And that would cancel. Can I divide the other side by 3? Absolutely, because whatever I do to one side, I got to do the other. So now I'm left with x minus 2 equals 4. Now all I got to do is add 2. Add 2. X equals 6. Same thing. Another way to attack the problem. Understand? Yes, sir.
Could you just plug in a number?
Could I just plug in a number?
Yeah, like could you just plug in 6 for x? 6 minus 2 would be 4. 4 times 3 is 12.
This is one thing I really like about equations is when you end up with an answer, for example, we got 6, we can plug it in to see if it works. Now, you're not wrong. You could just plug a number in the first place, but you're just kind of guessing and checking, which works. It's just if you're not very lucky guesser, then you might be working on it a really long time. Okay? But at the end, we absolutely need to plug it in. 3 times 6 minus 2 equals 12. Well, 6 minus 2 is 4. 3 times 4 is then we know it works. So we don't even actually need answer keys for solving equations. Once we get an answer, we can plug it back in. If it works, we're right. If it doesn't, we're wrong. We did something wrong. Isn't that interesting? Oh, yes, Coach Herman, it is. All right. What if we have variables on both sides? I want to jump all the way down here. Because this is important to me, not to you. What if we have variables on both sides? Well, there's two things we need to do. First, somebody said it. We need a CLT. I know, I don't mean to make you hungry thinking of a BLT, bacon, lettuce, and tomato. That's not what it is. It's CLT, which is combined like terms. First of all, what are like terms? Like terms are the same variable to the same power or same degree. Okay, so for example, 2x and 4x are like terms. Start with, when you're CLT, just dealing with one side of the equation. So 4x plus 2x is 6x minus 8 equals 3x. Those numbers or constants are like variables. They don't have a variable. So that's minus 14. Once we get to this point, this is my advice to you. And I'm always going to say this to you. And I'm going to be not upset, not mad, disappointed. That's probably a better word. When you deal with the number first. Every student I've ever had that deals with the numbers first seems to struggle at solving equations. Okay? Deal with your variables first. So I have variables on either side of the equal sign, yes? I got to get them together. I'm trying to isolate them anyhow, right? So I don't want them all spread out. I want to get them together. I would also suggest that you move the small one first. Always move the smallest one. Which one are we going to move? The smallest one. Which one are we going to move? The smallest one. So in this case, I'm going to move the 3. How do I move a 3x across an equal sign? I use the inverse. I do the opposite. So it's minus 3x. Minus 3x. So I'm left with 3x minus 8 equals negative 14. Now it becomes easy to do because we're doing the problems the same way we have been the whole time. Now what? Add 8. Add 8. 3x equals negative 6. Divide by 3. Divide by 3. X equals negative 2. All right. Questions on what we're doing. You've done this before. Millions of times. I mean, over the last several years, you guys have had 90 minutes of math, yeah? You probably have done more IXL problems than I've even seen. Yes? All right. I'm going to go fast. This is not in your book. So if you want to write these down and try to keep up with me, please do. X plus 4, minus 4, minus 4. Cancels. X equals negative 16. Cool? Any idea what I just did there? Whew. Some people weren't even looking. Ready? M minus 9 equals 10. I would cover that up. Plus 9, M equals 19. Oh, these are easy. One-steppers. Right, Mr. Stein? That's easy, right? What do I do here? Divide by? Why negative 3? Because it's with the variable. N equals 9. What do I do here? Multiply. Why? It's division. Why 9? Because it's with the variable. 3 times 9? 27 equals N. All right, enough of the easy stuff. Let's get to two-steppers. Get to stepping. Combine like terms. 2n equals 0. Divide by 2. N equals 0. Combine like terms. 5v equals negative 5. Divide by 5. V equals negative 1. Do I have to show my work every single time? I hope not. I hope not. I hope that you can start looking from one line to the next and I don't have to write divide by 5. Divide by 5. Okay, because I want to move. I want to get fast. Negative 11 equals negative 4x plus 1. Negative 12 equals negative 4x. Positive 3 equals x. Who did I lose? Lost you, didn't I?
Yeah, why'd you put the one in there?
Because I like my variables to come first. Don't you? Y equals mx plus b.
Yeah.
Standard form. Get your terms lined up. Make them high to low. I just like them first. Does it matter? It does to me, but not really. How about this one? 18 equals 9r, 2 equals r. That's how fast I want you to be able to go. Question what I did. Who can tell me what I did? Very good. Combine like terms and divided by 9. 15. Negative 7k minus 1 equals negative 1. Negative 7k equals 0. K equals 0. I don't know if it's the masks or what, but I'm having a hard time reading your eyes or whether you're with me or not. 17. Negative 8 equals negative 8 plus 8x. 0 equals 8x. 0 equals x. What do I do first? Right? I'm glad. Thank you for being honest. Okay, what was the very first thing I did? How do I get from this line to this line?
You have to move the variable over.
I said I moved the smaller one, right? I always deal with my variable first. I move the smaller one. Which one's smaller, 2x or negative 6x? So I added 6x to both sides. Do you see it? 2x plus 6x is, that's all I did. All right, how do I get to this line?
Don't you have to move the negative 8 over to the other?
Yeah, remember I would cover up the variable, so I'd have to add 8x to both sides, right? So cancels on one side, negative 8 plus 8 is 0. Then what?
You divide it by 8.
I need you to get from where you are to here. Number 19. 7 equals 10 plus 3p. What'd I do?
You move the 4 over to the 7.
Everybody see how I moved? I subtracted 4p. Negative 3 equals 3p. What'd I do, Mr. Stein? You're a step behind. We're in the next line. Mr. Roman? No, I didn't divide yet. Not what I want to do next. What did I just do from this line to that line? Not 7. 10. Subtracted 10. Why did I move the 10? Because it's with the variable, right? And I want that variable by itself. So minus 10, that cancels. Minus 10, right? I need you to see it without me writing it. Now what? Divide by 3. Negative 1 equals p. Last one I'm going to do. 21. 9a equals 16 plus 7a. 2a equals 16. A equals 8. I feel like this is fundamental. Like, if you were going to play basketball, you got to be able to dribble and shoot. If you can't dribble and shoot, probably not very good. Can't solve equations, probably not very good at math. So we got to be able to do this. Questions, comments, concerns. You have a sheet on your Google Classroom. Okay? You have a page on your Google Classroom. You're doing all of those questions. All of them. Pull it up. You're copying them down anyhow. There is also another video. If this was not enough, there is another video of me showing you a little bit slower, actually much slower, how to solve equations. Videos there. And then here is your problems. You got to do all of them. Y'all have a great day.